Okay, so we are going to use the light equations to solve for frequency and energy. So frequency here and energy here given our wavelength. That's why those boxes are empty. We're going to solve for those. I'm going to start with the red one and just sort of walk you through using these two light equations up here. So our first one is wavelength, right? We're given wavelength, and in our equations, this is the only place wavelength occurs. So we're going to use this C equals wavelength times frequency in order to find frequency. That's the first one we're going to find. So C equals wavelength times frequency. So C is a constant. It's the speed of light. So that's 3.00 times 10 to the 8 meters per second equals wavelength, which is 656 nanometers times the frequency. Sometimes you see frequency written as a V. You can see that up here. Like sometimes it's written like that as a V and sometimes as an F. Both are fine. So first thing I want to point out here is that our meters and our nanometers do not match. We cannot solve this equation until those units match. So we have to do a little bit of converting our nanometers into meters. So I'm just going to do that like down below, just out of the way. Eventually you're probably going to be able to do it just in your head, but I'm just going to show you the work. Whoopsie, not meters, nanometers. Okay, so I'm showing you the conversion. So nanometers goes on the bottom, meters goes on the top. That's what I need to convert it into because that's what the speed of light is in. So for every 1 meter, I have 1 times 10 to the 9th nanometers. So a lot of nanometers. So I'm going to take my 656 and divide it by 1 times 10 to the 9th power and get, which gives me 6.56 times 10 to the negative 7 meters. So that's the number I'm now going to use in my equation. So again, to solve for this, I'm going to do 3.00 times 10 to the 8th, again, meters per second, and that equals 6.56 times 10 to the negative 7 meters, and then I'm going to multiply that by frequency. So I'm going to divide both sides by my 6.5, sorry, okay, 6.56 times 10 to the negative 7 meters, and then 6.56 times 10 to the negative 7 meters. So with my meters in the numerator up here, my meters in the numerator here, and my meters in the denominator there, it cancels. When I divide those two numbers, I get 4.57, 3 sig figs, since I was given 3 in my wavelength, times 10 to the positive 14. And those units then are like no units over seconds. So the units are 1 over seconds. That's the same thing as hertz. So that's why it says hertz here in the table, is because hertz is the same thing as 1 over seconds. So there is my frequency. Now I'm going to solve for energy. I'm just going to take this information up here. So I solved for frequency. It was 4.57 times 10 to the 14, and that was in hertz. Now I can take my frequency and put it into this equation. So E equals Planck's constant times frequency. So Planck's constant is here, right below the table. So energy is what I'm looking for this last box down here. So my Planck's constant is 6.626 times 10 to the negative 34th joules times seconds. So both of those are in the numerator. And then I'm going to multiply that by the frequency that I calculated. So 4.57 times 10 to the 14. And remember that was over seconds. Hertz is the same thing as over seconds. So here I have seconds in the numerator and seconds in the denominator. So my energy is going to be measured in joules. If it asks you for kilojoules, you do have to do that last conversion step. But I'm just going to multiply those two numbers together. And I get, let's see, 2.6, how many sig figs did I need? 3. So 2.69 times 10 to the negative 16 joules. So there's my answer for energy. Your frequency should pretty much always be like times 10 to the 14. Like 14 is the visible range, times 10 to the 14. If you get like times 10 to the 15 or 16, it might just be because you're in a different range of light, so not necessarily invisible. You could be in like ultraviolet or something like that. Same thing with energy. It should, like for visible, it should be around times 10 to the negative 16. If you're getting like times 10 to the negative like 40 something, you did it wrong. So double check how you put it into the calculator. Same thing with frequency. If you're getting like times 10 to the, like 30 or 40, then again, you're doing it wrong. You probably put it into your calculator wrong, and you probably forgot to use parentheses, so double check that. If you want to try green, blue, and violet, go ahead and do that. I'll put the answers like in the discussion on Canvas if you want. If you're doing that, please email me and let me know so I can get those answers up there for you. But that's about it. Hopefully that example helps.